Again, general TFF operation at the industry, so you have to make sure that the entire unit is all washed well, and then do the clean in place using sodium hydroxide solution that can get rid of whatever the contaminants that may be still there. Once you did the sodium hydroxide wash, you have to remove sodium hydroxide from the system by doing a lot of wash with UFI. When you do that, when you do the flushing with UFI again after CIP, you can do the validation check, okay, to make sure that the membrane system is intact and then there's no clogging in the system. So that's what NWP/integrity test is. We'll talk about what that is, okay? And after your operation, if that system passes your test, of course, it is ready for your operation. So you will carry out your operation, and then the CIP again, to make sure whatever the leftover will be all washed again, and then at the end you do the validation test again, NWP. So you do it twice, before you use it, after you use it, and cleaning. The reason is, this NWP testing will make sure that the system is still intact, there's no damage, and then the washing is all done, so there's nothing is clogging up your tubings or the valves and systems. So that's why you do it twice, at the beginning and at the end. So the testing values should be similar. If they are showing the different values, that means there's some kind of clogging still in the system. That means your cleaning was not done thoroughly, so you have to do it again. Okay, makes sense? Okay, and then operation. So like I told you, flushing is the washing out the entire system with UFI, the water for injection, the clean water. That's what flushing is. And then CIP again, clean in place. The entire system will be cleaned using cleaning agent like sodium hydroxide solution. From 0.1 to 1 normal solution will be used to get rid of whatever the things that may be still in the system. And then so the clean in place again. Sometimes heat up your solution will help to get rid of whatever the residual clogging that may be in there. And then once that cleaning is done, you have to wash the entire system with UFI again to get rid of residual sodium hydroxide, right? After that's done, you do this testing. So NWP stands for Normalized Water Permeability Test. Okay, so your water permeability on your filter system is measured, and see how permeable your membrane is. If your membrane is not damaged, and if it's clean of any clogging materials, you will get certain value. Okay, so that's what you're trying to measure. So you will try to measure the permeate flow rate and the feed retentate and permeate pressure, and then water temperature. And there's an equation that you can use to calculate it out. So NWP, normalized water permeability, equals water permeate flux rate times temperature correction factor at 20 degrees Celsius. That's divided by membrane pressure. Okay, so that's the equation. Okay, so temperature compensation factor. So it depends on what temperature you're using for your operation. So 20 degrees it is a default 1, but if you do it under low temperature, you compensate it by increasing the factor. If you did higher temperature, the factor is going down. So and then how about the transmembrane pressure? So transmembrane pressure here, the bottom part of your equation. So that is measured as the feed pressure plus retentate pressure divided by 2. That's what the transmembrane pressure is. Okay, and normally the permeate pressure you consider as 0. Okay. So this is an example. So water flux rate is known to you as 110 liter per I guess whatever the size of the membrane is. And then the temperature compensation factor, if the operation is done at 16 degree, you can go back. 16 is about 1.11, so you have to multiply 1.11. Okay, and then and divide by the transmembrane pressure. What is the transmembrane pressure in this operation? About 10 psi. Okay, then if you calculate that, it becomes about 21.21 liter, whatever the unit is, divided by the PSI, the transmembrane pressure. So that's how you can calculate the NWP. And then depends on the filtration operation, you may be asked to perform some other filter integrity test with that NWP. Integrity test means you're checking if there's any major damage on your filter. That's what it is. So it's a non-destructive testing you can easily perform. Okay, normally something like pressure decay testing, which is a simple observation of your operation pressure to make sure if there's no sudden decay, drop down of your pressure is happening. If you see a sudden drop down of your operation pressure, that means there may be a hole in your membrane. So that's why you're seeing the drop down, because pressure will be dropped because main flow may happen through the hole, so there will be more significant drop down of the pressure. That's a pressure decay. You can check that easily. That's one of the integrity tests that is routinely done. And then buffer equilibration. So you flush the entire system with the buffer that you are using for your operation. That's what it is. Okay. And once that's done, again you have to validate to make sure that's done. You check the pH if that is the same pH as your buffer. And then product processing, whatever the processing you're going to go through, concentration operation, diafiltration operation, or purification operation, just do that following the SOP. And if it's a concentration operation, at the end of the process, you will remove a whole bunch of your solvent only without losing your protein. So you will see a significant drop of your solvent, but without losing your API, so your protein will be still there, so the concentration will go up. Okay, and then diafiltration operation is similar to concentration operation. You are removing the buffer, and then at the end you are introducing a new buffer. That's a buffer exchange. Okay. And then product recovery, you can capture your product in permeate, or you can capture your product in retentate. Depends on the size of your product and how it is related to the pore size of the membrane. Okay, you can capture it from different place. And then after your operation, of course, you will do CIP again and UFI flushing. And while you're doing the UFI flushing, you will check the NWP test again. Again, why do you need to check it again? Because you're trying to make sure you clean the place, the entire filter and the tubing very well. So the NWP test you get at the end should be similar to the NWP value you got from the beginning. Okay, so that means yes, your system is intact, and then you have nothing that's still clogging the system. Okay, and then if you're not using the system for a long time, you can store it somewhere safe. Okay, so you may add some preservative in there, or if you are not going to use it for a long time, you can separate your membrane from the system. Okay, so that's how you can store. And there are some review questions here. TFF stands for what? Tangential flow filtration. Okay, that's the easy answer. And then these terms. Fouling means what? Choose that. HEPA filter is what? Flow rate is what? Find the definition. CIP means what? Retentate means what? Molecular weight cutoff means what? Filter rate means what? Okay. And then this is what? This is a dead end filtration, which is normally what? DFF, direct flow filtration. Okay, so that's what it's showing, which is not correct about TFF. Find the answer, and then matching the term with its definition: macro, micro, ultrafiltration. Okay, which of the following is incorrect? You find the answer and let me know. Same goes. So test your knowledge. Okay, through these questions. I'm not going to go over those. Okay, so that was the TFF and the filtration introduction. Okay, so another effective method of separating out a molecule is called the centrifugation. Centrifugation, I'm sure you have done the lab through the lab 1 already, right? You can separate out molecules based on their size, based on their sedimentation value. Okay, sedimentation means what? When you spin down your sample, some molecules will settle down at the bottom of the tube. Some molecules may be still floating. So sedimentation is, how quickly your molecule will settle down. So that has a lot to do with their sizes or their weight. Okay, those will affect the sedimentation. So it depends on the sedimentation difference, you can separate out your molecules. So using what instrument? That's a centrifuge, is the machine. Okay, the centrifuge can create a centrifugal force by rotating force, okay, at a higher speed, and centrifugal force will be applied to the molecules, and depends on the molecular size. Some of them will be facing a lot more force than smaller ones, and they will come down as a pellet much faster. Okay, that's how you can separate out your molecules. And then when you spin your sample, okay, so the speed matters, right? How fast you are spinning your centrifuge. So your spinning speed is expressed as RPM, revolution per minute. Within a minute, how many times your centrifuge will spin. Okay, that's RPM. And then if you want to describe the centrifugation condition as how much force is applied to your sample, okay, by that spinning that's created, that is described as the relative centrifugal force. Okay, so RPM is a speed, RCF is a force. Okay, normally RCF is given as a G, gravity force. Okay, so the RCF, the force, equals relative centrifugal field in the unit of G. Okay, it's expressed, and the centrifugal the equation, RCF equals about 11.2 times radius of your centrifuge. Okay, and that's multiplied by RPM divided by 1000 square. Okay, in other words, that is 1.12 times 10 to the negative 5 times RPM square times radius. Okay, so RCF is described in this way. In this equation, there's the radius right there. Okay, and if you want to write that equation RPM equals the speed of rotation per minute, of course, right? And the RPM equals 1000 times square root of RCF divided by 11.2 radius of your centrifuge. Okay, so what it's showing is RCF and RPM, they can be interchangeable if we use this equation. That's what it means. Okay. Many protocols describe the centrifuge speed unit in RPM. However, RCF is a preferred unit. What does that mean? What it means is when you describe how you set up your centrifuge, okay, to write a SOP or something, okay, do you describe your centrifugation condition as in RPM, how fast you need to spin your centrifuge, or you describe it as RCF, how much G-force you should apply to your sample? Okay, which one is a better method? That's the question. The better method is, it's RCF. That's a better method because RPM, it describes the speed of the rotor, but speed of the rotor is one thing, and then there's another thing you need to consider. That is, if you look at this equation, there's a radius of your rotor is also affecting the RCF, right? So if you only describe RPM, you don't know the radius of the rotor, because the radius of the rotor may vary, depends on what centrifuge you have, right? So because of that, when you describe your centrifugation condition, G is the right way of describing it. So G, if you describe it, you can consider whatever the radius of your rotor is. By adjusting your RPM, you can create a G. Okay, that's why it's a better way of describing your centrifugation in G, RCF format. Okay, and then if your centrifuge cannot spin very high speed, okay, G-force is low, then what is required? You can extend the centrifugation time to create a similar effect. Okay, so there's a time factor in your centrifugal condition. Okay, so your SOP requires maybe 10,000 RCF, but your centrifugation only can go up to 8,000. Then you can increase the time more to create the same effect. That's what it means. Okay.